In our last video, we talked about the atomic radius, and that's how big or small an atom is. It also can tell us a little bit about the length of the bond, or what we refer to as the internuclear distance. The distance between two different nuclei depends on how big the atom is. And today we're going to talk about something very similar, but this is referred to as the ionic radius. Okay, and clearly it's the same thing as the atomic radius. It just means that the atom has gained or lost one or more electrons. And so in this case, it's very similar to atomic radius, but what we have to do is many times we're going to have to compare the radius of an ion with the radius of an atom. So first of all, let's talk about what happens when you form an ion. So whenever you form an ion, you still have to think about protons and you still have to think about electrons, okay? Overall, when you form a cation, or that's a positively charged ion, that means you're losing at least one or more electrons. And since there are now the same number of protons, that hasn't changed, but now you have less electrons to attract. That positively charged ion will be smaller than the neutral atom, always, okay? Many times when you form a cation, you actually lose an entire valence shell. So if you lose the whole valence shell, if you had 3 shells and now you only have 2, so now you have the same number of protons, but now only 2 shells of electrons, they get way, way smaller. Okay, and so yes, a positively charged ion always gets smaller, but if you lose a whole shell where now you have less electrons to attract, the same number of protons and fewer shells, you get the decrease is dramatically smaller in size. Okay, and the opposite's also true when you have an anion, which is a negatively charged ion. So here you've lost electrons. Here you will have gained electrons. Now you've added more electrons to that same area. So by doing so, you're increasing, this is the important part, increasing the repulsion between one electron and another. By trying to fit another electron in there, you're now increasing the repulsion that exists between 2 electrons, or what we refer to as the electron-electron repulsion, without changing the number of protons. And what that does is you try to include another electron in there, and of course the other electrons basically have to make space for it, and that's going to make the anion larger than the corresponding neutral atom. So cations always get smaller because the same number of protons, and now you have less electrons to attract. Anions always get bigger because you have the same number of protons, but now you have more electrons to attract. And here you're increasing the electron-electron repulsion, okay? Whereas here, there are less electrons to attract with the same number of protons, so the remaining electrons are drawn closer to the nucleus. Okay, those are kind of if you have to explain why, that's the why right there. Okay. So here's just a graph of that. There's a table that kind of shows that. Okay, so you can see that in both cases, the gray is the original atom. Here on this side, those are the positively charged ions. Those are the cations. And over here on the right-hand side, those are the negatively charged ions, the anions. So notice that every single pink one is smaller than the gray one. Okay, so the neutral atom is gray. The pink is the ion, or the positively charged ion. So they always, always, always get smaller. You can see that over here on the right-hand side. Again, the gray is the original atom, and then the blue is when it's now gained one or more electrons. So the negative ions always get bigger. Cations, positively charged ions, always get smaller. So using principles of atomic structure, explain why the ionic radius of Cs plus is less than the atomic radius of xenon. So you might look at that and go, okay, well, cesium has lost an electron, and now it has the same number of electrons as xenon. okay, they're never going to have a trick question on the AP test. You're not going to say this is false. Okay, it's always true. Unless they say true or false or agree or disagree, then of course it's true. Okay, so they're saying that CS plus is less than the radius of xenon, and how could that possibly be when they have the same number of electrons? Well, because cesium, even though it lost an electron, its protons did not change. So even though they are isoelectronic, oh, remember that fancy word? They have the same number of electrons. So they are isoelectronic. You don't have to use that word. But cesium still has one more proton. So one more proton means the attraction's a little bit stronger in cesium than it is in xenon. So cesium plus is going to be smaller than xenon would be. Okay. So there's more attraction in cesium. Cesium has one. That's what the grader's going to be looking for. Are those words right there? Okay. Example 2. Place the following atoms or ions in order of increasing size. Justify your answer. Sometimes when I see that, I think, okay, that means start with small and go to big. So which of those is going to be the smallest? You've got neon, magnesium 2 plus, and oxygen 2 minus. So let's just kind of go through them. Neon has 10 protons, 10 electrons. Magnesium 2 plus has 12 protons, and with its plus 2 charge, it's lost 2. So it has 10 electrons, and O2 minus, not 10, I'm going to write 10 in a second. O2 minus has 8 protons, and again 10 electrons. So again, notice that all 3 of them are isoelectronic. So which one's going to be, again, in increasing size means start with the smallest, go to the biggest. Which of these is going to be the smallest? Don't say they're all the same size, because again, that means that their question is wrong. If they say put it in order of increasing size, you say this is false, they're all the same size, you're going to be wrong. Okay? So which one's going to be the smallest? It's similar to the cesium one up here. It's since the electrons are the same, it has to be the protons. The more protons there are, the stronger that attraction is, the more it pulls those electrons in. So which one's the smallest? Mg2 plus. Why? Because it has the most protons. And then what's next? Neon. Okay, it has 10 protons. And then which one's going to be the biggest out of all of them? O2 minus. Okay, and then to justify your answer, what's the grader going to be looking for? And, same number of electrons. I would just identify this. And then Mg2 plus has the most protons. O2 minus has the fewest protons. Okay? More attraction in Mg2 plus, less attraction in O2 minus. Okay, example 3 says a student finds the following particulate model of AgCl. So down here below, okay, assuming the crystal structures are similar, how should the student modify the model to represent AgI? Justify your answer in terms of the radius and the arrangement of electrons in the atom. So first of all, we look at the periodic table and we see that iodine is much, much lower on the periodic table than chlorine is. So this is Ag plus and Cl minus, and this is Ag plus and I minus. Okay, so how would you modify this model here to represent AgI instead of AgCl? Well, in terms of the arrangement of the ions, of the electrons in the ion, and then the radius. Whoa, what did I do there? Okay, really all that you would need to show is that in terms of the arrangement of the electrons in the ions, basically you want to just say that iodine minus has more electron shells. And if it has more electron shells, then the radius is going to be, the I minus radius is bigger. So how would you modify this? You'd make those circles, the Cl minus circles, bigger. Okay, and you turn them into I minus. So the diagram should show that I minus is larger than Cl minus because iodine has more electron shells than chlorine does. Okay, and that's all you would have to say there. Okay, and that is our introduction to ionic radius. Now let's do some practice problems with it in our packet.